In this video, we will start with circular system of measurement of angles. What we do in circular system of measurement of angles is, suppose you have this circle, you have any circle, and say you have points on this circle A, B dash. Okay, this is your circle, B dash is your circle, and you want to define a system, a circular system of measurement of angle. So basically we need to define an angle, okay, in terms of which all other angles will be measured, all other angles will be measured. So basically we need to have an angle, okay, that will be our base, and all other angles will be measured in terms of this angle, right? For that, what we do is take any point on the circle. For example, I start with A. This is the center of the circle O. I'll join OA. Now this is the radius R of the circle, small r. Then starting from A, I'll cut an arc along the circle with length equal to R and call that point P and join OP. Okay, now this arc AP will subtend some angle at the center, and we will call that angle equal to 1 radian. This angle will be called a radian. Okay, so basically what you have done is you have started from the point A, and arc AB, length of arc AP should be equal to R, then angle AOP is 1 radian, and this this is the angle in terms of which all other angles will be measured. So this is the base in case of circular system. This is the base in case of circular system, right? Now we have here taken an arbitrary angle, so we need to prove that actually this 1 radian, this is independent of the circle. Whether I take a small circle or a large circle or a medium circle, the measurement of this angle should be constant. Only then we can use it as a base for the circular system. So I need to prove that this quantity 1 radian is actually a constant quantity. So let's see how we prove that. For that we need three things. First I'll prove that my aim is to prove that magnitude of this angle 1 radian is constant, that is independent of the circle. Whatever circle you take, independent of the circle. This is my aim. This is what I want to prove. The first thing I will prove is that for a circle, circumference upon radius, circumference is to radius is constant. This is the first thing we will prove, right? So we'll start with this thing. We'll prove that circumference upon radius is a constant quantity. So it means that if you have a circle, small circle, you have a large circle, you take the circumference of this circle, divide it with the radius, you'll get some number, okay, and that number is same as if you divide the circumference of this larger circle with the radius of this circle. So that is independent of circle. The circumference is to radius, this ratio is independent of the circle, so that is a constant always. So I'll prove this thing. For proving this thing, suppose I have two circles. Consider these two circles. I have have a smaller circle, I have a larger circle, right? Suppose these are the concentric circles. Suppose this is a center O. Now in the larger circle, you in the larger circle, sorry, take a regular polygon with n sides. What is a regular polygon? This is a polygon with equal sides, right? Now in the larger circle, we are taking a polygon with n sides. Suppose this is A, then this is B. These are the vertices of the polygon, C and D and E, F, something like this. So I have a polygon of this kind. Just a minute, I'll change the color so that you can have a better look. So you have a polygon of this type, this, this, like this. You have a polygon and so on, right? Join this. Similarly, you will cover this whole circle. You can do that. Now join this O with A, O with B, O with C, and so on. These lines will intersect the smaller circle at some points. Let us call those points. Call this small a, small b, small c, and so on. You can carry on, right? Now see this thing. You have, since OA is equal to OB and O capital A is equal to O capital B. You have OA is equal to OB because these are the radius of small circle, radii of small circle, and then you have O capital A is equal to O capital B. These are radii of larger circle, right? It means that the lines AB and capital A capital B, these two lines are parallel, right? Now let me draw this triangle, these two triangles. You have something like this. This is your O, this is your small a, this is your small b, this is your capital A, this is your capital B. Basically, I have drawn these two. I have drawn these two triangles here, and you are saying that this is parallel to this. So it means that this angle is equal to this angle, and this angle is equal to this angle. These are the corresponding angles. You have parallel lines. So this angle is equal to this angle, and this angle is equal to this angle. Now consider this triangle OAB and triangle OAB. You have this angle common. Angle, this, call it 1. Angle 1 is common. Angle OAB is equal to angle OAB, and angle OBA is equal to angle OBA. Okay, so it means that these two triangles are similar. It means that triangle O, these are the triangles, OAB is similar to triangle OAB. Now if these two triangles are similar, it means that AB upon small ab is equal to OA upon O small a. Okay, you get this thing. Now see, what is the parameter of the parameter of the polygon, the regular polygon in the larger circle? We know that the number of sides were n and each side is, see, one side is AB, the one side is AB, and similarly for the corresponding polygon, regular polygon in the smaller circle, the corresponding side is small a small b, right? So you have parameter of the regular polygon in the larger circle is n times side AB, because sides are equal, and parameter of the regular polygon in the smaller circle is equal to n into small a small b. Okay, so therefore we have parameter of sorry, smaller, not smaller, okay, fine, parameter of outer polygon is to parameter of inner polygon. What is this? This is equal to n times capital A capital B, n times small a b. This is AB upon small ab, and from this equation this is same as OA upon OA. Okay, so it means that parameter of outer polygon divided by parameter of inner polygon is equal to radius of outer circle, OA is radius of outer circle, upon radius of inner circle. Now there is no restriction on the number of sides of the polygon. We can take any number of sides of the polygon. Let n, which is the number of sides of the polygon, goes to infinity. Now when n is going to infinity, the polygon will actually coincide with the circle. Okay, can you see that? If there are infinite number of sides of the polygon, then basically we are coinciding with the circle itself. Therefore when n is going to infinity, in that case parameter of the outer polygon is actually the circumference of the outer circle. In that case we have, this is true for every case, so in particular this case we have circumference of outer circle divided by circumference of inner circle is equal to radius of outer circle divided by radius of inner circle. Therefore circumference of outer circle divided by circumference of radius of outer circle. I'll take that radius from, I'll take this here and I'll take this there. I'll interchange these two things. I'll get circumference of outer circle divided by radius of outer circle is equal to circumference of inner circle divided by radius of inner circle. Now can you see what is happening? You are you can observe that this quantity for the bigger circle is same as the same quantity for the smaller circle. It means that this is actually a constant quantity. Okay, it means that circumference upon radius is constant, is equal to a constant, right? If circumference upon radius is constant, it implies that circumference upon 2 times radius is also a constant quantity. Now what is 2 times radius? This is diameter of the circle. So I have circumference upon diameter is equal to constant, and this constant is actually equal to pi. This pi is an irrational number. This pi, this is an irrational number. Okay, its value up to 8 decimal places is 3.14159265, 3415 and so on, 341514159265. And 22 7 pi is approximated with 22 pi by 7. This is up to 2 decimal places. This is correct up to 2 decimal places, but we generally approximate pi with 22 pi by 7. Okay, its value is 3.14285. You can see that after the decimal only the first two values are matching. Okay, more accurate value of pi is, you can approximate 355 divided by 133. Okay, sorry, 113. This is equal to 3.14159203. So you can see that this is correct up to 6 decimal places. Correct up to 6 decimal places. You can see this, the first 6 values, these values are matching. This is the correct value of pi up to 8 decimal places. This is the exact value of pi, correct value of pi up to 8 decimal places. Okay, so this is this 22 by 7, this approximation is correct up to 2 decimal places, and this 355 divided by 113, this is correct up to 6 decimal places, right? Now we have proved that circumference is to diameter. Circumference divided by diameter of a circle is a constant quantity. Now next is, what was our aim? We wanted to prove that pi is actually a constant thing. What we proved is, we proved that circumference upon 2r, if r is a radius, is equal to pi. So it means that we proved that circumference is equal to 2 pi r. We proved that circumference of a circle is 2 pi r. Now I had this circle. Okay, what was the definition of radian? This was the point A, and this is r. This was the point P, such that this length is r. Then this was 1 radian. Okay. Now take B here, such that angle AOB, take point B, such that angle AOB is equal to a right angle. Right? Now we know that from geometry, if you have two arcs on the circle, this is your circle, you have two arbitrary arcs. This is AB, this is one arc, and this is some CD arc. Then this is your center O. Then length of AB upon length of CD, ratio of length of AB upon length of CD is same as ratio of the angles subtended by the arc on the center of the circle, is same as theta 1 is to theta 2. Okay, so here we have this arc. We have this arc AP and this arc AB. Okay, length of AP, arc AP divided by length of arc AB is equal to angle subtended by AP. Now what is the angle subtended by AP? This is 1 radian. This is the definition of 1 radian. This is 1 radian divided by, what is the angle subtended by AB? This is 1 right angle. 1 right angle. Now what we know, length of AP is R. This is equal to R. This is the known quantity. Now just a minute. This is your R. Now what is the length of AB? We have we can see that length of AB, this is 1/4 of the circumference. This is one quadrant. This is the first quadrant. So length of AB is basically 1/4 of the circumference. This is 1/4 of the circumference. Now what is circumference? Circumference is 2 pi r. So this is equal to pi r by 2. So we have this quantity is equal to, this quantity is equal to pi r by 2. Therefore we have r upon pi r by 2 is equal to 1 radian divided by 1 right angle. 1 radian divided by 1 right angle. So it means that 1 radian is equal to, r cancels, 2 by pi right angles. So you have 1 radian is equal to 2 by pi right angle. Okay, now you can convert it into degrees. We know that 1 right angle is equal to 90 degrees. So this is equal to 2 by pi into 90, these many degrees. So 1 radian is equal to 180 upon pi degrees. First of all, can you see this is a constant quantity? Because pi is a constant quantity. So 1 radian is a constant quantity. This is what we wanted to prove. Okay. Now 180 divided by pi degrees, and this is nearly equal to 57 degrees, 17 minutes, 44.8 seconds. Similarly, you can convert it into grades also if you want, and so on. And you should note that one right angle, one from here we can see one right angle is equal to pi by 2 radians. This is important. Okay, this was the circular system for measuring angles. Thank you.